Impact forecast: 40% reduction in sustainability effectiveness across 4 industries by 2025. Date: January 30, 2025. The projected 40% reduction in sustainability effectiveness across 4 critical industries, agriculture, automotive, construction and IT, by 2025 highlights a significant challenge faced by these sectors in achieving their sustainability targets. This report delves into the common challenges and distinctive approaches across these industries, underscoring the urgent need for transformative efforts and innovative solutions. Common challenges across industries. 1. Sustainability obstacles. Automotive sector: while strides have been made in reducing emissions from manufacturing processes, the operational phase of vehicles continues to be a primary source of greenhouse gas emissions. The transition to electric vehicles (EVs) is imperative, yet the pace remains inadequate to meet regulatory targets. Agriculture: this industry grapples with resource management problems, particularly in water use and fertilizer application. Sustainable practices are often hindered by traditional methods and insufficient technological integration. Construction: the sector faces significant waste management challenges and energy inefficiencies as it shifts towards sustainable building practices. The need for sustainable materials and efficient designs is increasingly critical. IT: the IT industry is under pressure to reduce its carbon footprint, particularly in data centers. The rapid proliferation of digital services adds to energy consumption and electronic waste. 2. Technological integration. Across these sectors, artificial intelligence (AI) is emerging as a transformative tool. In agriculture, AI enhances precision farming through improved irrigation and crop monitoring. In manufacturing, AI optimizes production workflows, reducing waste and energy consumption. The integration of smart technologies is recognized as essential for enhancing operational efficiencies and managing resources effectively. 3. Regulatory frameworks. The introduction of stringent regulations such as the EU Green Deal compels industries to adapt to sustainable practices. The automotive sector, for instance, must comply with binding emissions reduction targets and increasing electrification mandates. Similar regulatory pressures in construction emphasize the necessity of sustainable materials and energy-efficient designs. Industry-specific insights. Automotive sector. The automotive industry reports a 20% reduction in emissions primarily through energy efficiency measures. However, this is insufficient to meet the required 4.2% annual reduction necessary to align with climate goals. The sector must accelerate the adoption of EVs and address emissions throughout the vehicle lifecycle. Agriculture. AI technologies in agriculture, such as precision irrigation and pest prediction, are projected to drive significant improvements. However, the sector must overcome traditional practices and enhance the integration of innovative solutions to optimize resource use and minimize environmental impact. Construction. The construction industry is increasingly focusing on circular economy practices to reduce waste, while initiatives to utilize recycled materials are progressing. Broader adoption is essential to achieve sustainability targets. Innovative design strategies and sustainable construction practices are crucial for mitigating environmental impacts. IT sector. The IT industry's sustainability efforts are predominantly focused on energy efficiency in data centers. The challenge lies in balancing the increasing demand for digital services with the need for reduced energy consumption and waste management. The implementation of greener technologies and practices is vital for improving sustainability effectiveness. Timeline of events. 2019, the EU Green Deal is launched, setting ambitious goals for decoupling economic growth from resource consumption and reducing greenhouse gas emissions by 2050. 2023, the automotive sector showcases a 20% reduction in emissions from operations. However, overall emissions reductions across the value chain remain slow, indicating a significant gap in achieving climate goals. 2025 forecast: a projected 40% reduction in sustainability effectiveness is anticipated across key industries, highlighting the urgent need for accelerated efforts in achieving sustainability targets. Future outlook: by 2025, AI is expected to play a pivotal role in enhancing sustainability initiatives across these sectors. The adoption of innovative technologies alongside compliance with evolving regulatory frameworks will be essential for improving sustainability effectiveness. Conclusion: the forecasted reduction in sustainability effectiveness poses significant challenges across agriculture, automotive, construction, and IT sectors. While progress has been made, the integration of AI technologies and adherence to stringent regulatory frameworks will be critical in navigating these challenges. The automotive sector in particular must prioritize the transition to electric vehicles and address emissions throughout the vehicle lifecycle. Simultaneously, agriculture, construction, and IT must embrace innovative solutions to enhance sustainability effectiveness and meet future targets. As industries confront these challenges, a collective commitment to sustainability will be vital for driving meaningful progress towards a greener future. The path forward requires bold actions, collaborative efforts, and a shared vision of sustainability that transcends individual sectors. The forecasted 40% reduction in sustainability effectiveness across agriculture, automotive, construction, and IT industries by 2025 presents several layers of counterintuitive information that challenge conventional wisdom regarding sustainability progress. Here are some of those insights. 1. Technological advancement versus sustainability effectiveness. While technological integration, particularly through AI, is often seen as a direct pathway to improved sustainability, the anticipated reduction in effectiveness indicates that technology alone may not suffice. The reliance on AI for operational efficiency, waste reduction, and resource management may lead to short-term gains but can overlook broader systemic issues within industries. For instance, even as AI improves production processes or enhances precision in agriculture, the overall resource consumption and emissions may not decrease proportionally, particularly if industries continue to scale operations without addressing fundamental consumption patterns. 2. Emissions during use phase. In the automotive sector, significant emissions reductions have been accomplished during the manufacturing phase, yet emissions during the vehicle use phase remain a substantial challenge. The counterintuitive aspect here is that while manufacturers achieve tangible improvements in production emissions, the overall effectiveness in reducing total lifecycle emissions declines, highlighting a gap in addressing the full environmental impact of products. The focus on electric vehicles (EVs) may also mislead stakeholders into thinking that transitioning to EVs alone will solve the problem, while the actual emissions during the vehicle's operational life remain unaddressed. 3. Circular economy challenges. The transition to a circular economy is often heralded as a major advancement in sustainability. However, the reality is that industries struggle with the complexities involved in implementing circular practices. The decline in the use of secondary materials, as reported, contradicts the expectation that circularity should naturally follow as industries adopt more sustainable practices. The notion that simply increasing recycling rates or using more recycled materials will lead to sustainability effectiveness fails to recognize the systemic barriers that prevent such transitions, including market readiness, consumer behavior, and regulatory challenges. For a regulatory frameworks versus industry response, the expectation that stringent regulations such as the EU Green Deal will automatically lead to improved sustainability outcomes is challenged by the forecasts. While regulations are intended to compel industries to adopt more sustainable practices, the reality is that compliance can often lead to minimal adjustments rather than transformative change. Industries may focus on merely meeting the standards rather than innovating beyond them, leading to a situation where regulatory compliance is confused with genuine sustainability progress. 5. Market dynamics and consumer behavior. The automotive industry's recent stagnation in electric vehicle adoption despite overarching sustainability goals, highlights the disconnect between market dynamics and sustainability objectives. The expectation was that increased EV production and consumer demand would drive emissions reductions. However, factors such as affordability, range anxiety, and insufficient infrastructure have counteracted these efforts, demonstrating that consumer behavior and market conditions can derail even well-intentioned sustainability initiatives. 6. Biodiversity and sustainability trade-offs. The drive for sustainability in one area, such as electrification, and the demand for raw materials like lithium can lead to biodiversity loss and environmental degradation in another. This counterintuitive outcome illustrates the complexity of sustainability efforts, where actions taken to reduce carbon footprints can inadvertently harm ecosystems. For example, mining for battery materials often disrupts natural habitats, posing challenges to biodiversity conservation that are not immediately evident in straightforward sustainability metrics. 7. Overemphasis on emissions metrics. The focus on emissions reductions as the primary metric for sustainability effectiveness can be misleading. While reducing greenhouse gas emissions is crucial, other factors such as water usage, soil health, and social impacts are equally important for a holistic view of sustainability. The projection of a 40% drop in effectiveness suggests that an over-reliance on emissions data may obscure other critical sustainability dimensions, leading to an inadequate response to environmental challenges. 8. Anticipated innovations. Competing with existing practices. As industries strive to innovate and adopt new technologies, existing and entrenched practices can hinder progress. For instance, in agriculture, while AI can optimize irrigation and crop management, traditional farming practices may persist due to habit or resistance to change. This indicates that the rate of technological adaptation may not keep pace with the necessary shifts in operational practices required to achieve meaningful sustainability improvements. These counterintuitive insights illustrate the complexities and challenges facing industries as they navigate sustainability goals. The expectation that technological advancements, regulatory pressures, and market dynamics will seamlessly lead to improved effectiveness overlooks the multifaceted barriers that remain in achieving true sustainability across sectors. The forecasted 40% reduction in sustainability effectiveness across key industries by 2025, particularly in agriculture, automotive, construction, and IT, highlights a significant challenge that could reshape the future of these sectors. While many of the common key points in the report address the overarching issues and trends, there are critical details and insights that are often overlooked, which merit deeper exploration. Significance of the 40% reduction forecast. One of the key elements that many might miss is the specific implications of a 40% reduction in sustainability effectiveness. This statistic is not just a number. It indicates a potential failure to meet international climate commitments and sustainability goals. A decrease of this magnitude suggests that industries are not only failing to keep pace with regulatory requirements but are also regressing in their sustainability efforts. This regression could have dire consequences, including increased greenhouse gas emissions, higher operational costs, and loss of competitive advantage in global markets. Biodiversity and ecosystem impact. The report emphasizes that the automotive sector's shift towards electric vehicles (EVs) is critical for emissions reduction. However, the environmental implications of sourcing materials for EVs, particularly lithium and cobalt, are often overshadowed by the focus on emissions. The extraction of these materials can lead to significant biodiversity loss and habitat destruction. This aspect is crucial because it raises questions about the net environmental benefits of transitioning to EVs if the supply chain is not managed sustainably. It underscores the importance of adopting a holistic approach that considers the entire lifecycle of products, from raw material extraction through to end-of-life disposal. Regulatory frameworks and compliance. Another important but frequently overlooked detail is the role of evolving regulatory frameworks. For instance, while the EU Green Deal sets ambitious targets for emissions reductions, the compliance mechanisms and penalties for non-adherence remain less discussed. The introduction of the Corporate Sustainability Reporting Directive (CSRD) and its implications for transparency and accountability in reporting are vital. Companies that fail to comply with these regulations could face substantial fines and reputational damage, creating a significant incentive for them to prioritize sustainability in their operations. The nuances of these regulations and the potential impacts on business models are areas that require more attention. Technological integration and AI's role. The integration of artificial intelligence (AI) across industries is noted as a major factor in enhancing sustainability. However, the specific applications of AI that could have the most significant impact are often underexplored. For instance, while the report mentions AI in agriculture for precision irrigation and crop monitoring, it does not detail how AI can revolutionize supply chain management by predicting crop yields and optimizing logistics to reduce waste. Additionally, the potential for AI to facilitate circular economy practices by improving recycling processes and enhancing product longevity is another crucial dimension that deserves more emphasis. Circular economy practices. The shift from a linear to a circular economy is touted as a necessary transformation. Yet the practical steps and challenges associated with this transition are not thoroughly examined. For example, the complexities of implementing circular practices in the automotive industry, such as recycling battery materials and creating closed-loop systems, are significant barriers that need to be addressed. Furthermore, the economic incentives for companies to adopt circular practices, such as cost savings from reduced material usage and enhanced brand loyalty from environmentally conscious consumers, are often overlooked. A deeper exploration of these economic drivers could provide a more comprehensive understanding of the transition to a circular economy. The role of consumer behavior. Consumer behavior is another critical factor that influences sustainability effectiveness but is frequently underestimated. The report indicates that regulatory pressures are driving industries towards sustainability, yet it does not deeply consider how changing consumer preferences and behaviors can impact these industries. For instance, as consumers become more aware of environmental issues, their demand for sustainable products increases. This shift can compel companies to innovate and adapt their practices to meet consumer expectations. Moreover, the role of education and awareness campaigns in shaping consumer choices can have a significant impact on the effectiveness of sustainability initiatives. Economic viability of sustainability initiatives. The economic feasibility of implementing sustainability initiatives is a vital aspect that often gets sidelined. While companies may recognize the importance of sustainability, the upfront costs associated with transitioning to greener practices can be a barrier. The report mentions investment in low-carbon technologies, but it would benefit from discussing financing options, government incentives, and partnerships that can alleviate some of the financial burdens. Understanding the economic landscape surrounding sustainability initiatives is crucial for fostering a more favorable environment for innovation and transformation. Sector-specific challenges and innovations. Each of the four industries faces unique challenges that significantly impact their sustainability effectiveness. For instance, the construction sector is grappling with waste management and energy efficiency, yet innovative approaches like modular construction and sustainable materials are emerging. These innovations often receive less attention than they deserve. Highlighting successful case studies or pilot projects within each industry could provide valuable insights into best practices and emerging trends that can drive sustainability forward. Conclusion: a call for comprehensive analysis. In summary, the forecasted reduction in sustainability effectiveness across key industries is a multifaceted issue that requires a comprehensive analysis. The overlooked details such as the impact of material sourcing on biodiversity, the regulatory landscape, the role of technology, circular economy practices, consumer behavior, economic viability, and sector-specific challenges are critical to understanding the broader implications of sustainability efforts. Addressing these nuances will not only enhance awareness but also drive more effective strategies for achieving sustainability targets by 2025 and beyond. The conversation around sustainability must evolve to incorporate these dimensions, fostering a more informed and proactive approach to addressing the pressing challenges our industries face. The forecasted 40% reduction in sustainability effectiveness across the agriculture, automotive, construction, and IT industries by 2025 raises significant concerns about the future of sustainable practices in these sectors. An in-depth analysis of this situation reveals several critical insights that warrant discussion. 1. Sustainability challenges across industries. The fundamental challenge facing these industries is the multifaceted nature of sustainability hurdles. Each sector has its unique issues, yet they share common threads that hinder progress. Agriculture struggles with resource management, climate variability, and soil degradation. The emphasis on maximizing yields often comes at the expense of environmental health. Automotive faces a critical juncture in reducing emissions during the vehicle's lifecycle, particularly in the usage phase, which remains the largest contributor to greenhouse gas emissions. Transitioning to electric vehicles (EVs) is essential, but the pace is slow due to market hesitance and infrastructure challenges. Construction grapples with waste management, energy efficiency, and the need for sustainable materials. The sector's reliance on traditional building practices makes it difficult to implement significant changes quickly. IT must contend with the energy demands of data centers and the e-waste generated by rapid technological advancements. As reliance on digital solutions increases, so does the environmental impact of these technologies. These challenges underline the need for transformative strategies tailored to each industry. Fostering an environment where sustainable practices can thrive. 2. Technological integration and AI's role. The integration of AI and other technologies presents a significant opportunity to enhance sustainability across all sectors. AI can drive efficiency, reduce waste, and optimize resource management. For example, in agriculture, AI can facilitate precision farming, which optimizes water usage and minimizes chemical inputs, leading to improved yields without harming the environment. For the automotive industry, AI can streamline production processes, predict maintenance needs, and enhance the overall efficiency of vehicles, especially electric ones. Within construction, AI can aid in project management, ensuring energy-efficient designs and reducing material waste through better planning and execution. In the IT sector, AI can improve energy efficiency in data centers and optimize supply chains, significantly reducing the carbon footprint associated with digital infrastructure. By leveraging AI, these industries can not only comply with regulatory frameworks but also enhance their sustainability effectiveness in the face of impending reductions. 3. Regulatory frameworks and compliance. Stringent regulations such as the EU Green Deal are reshaping the landscape for sustainability across these sectors. The introduction of guidelines and targets compels industries to adapt rapidly. Key points include: automotive regulations mandate emissions reductions and increased electrification, pushing manufacturers towards a faster transition to EVs. Compliance with these standards is critical for maintaining market viability. Construction regulations emphasize the use of sustainable materials and energy-efficient designs, necessitating a shift in industry practices. Agriculture is increasingly being held accountable for its environmental impact, with regulations aimed at promoting sustainable farming practices and resource management. The pressure from regulatory frameworks acts as both a challenge and an opportunity, driving industries to innovate and improve their sustainability efforts. Companies that proactively adapt will not only meet compliance standards but also position themselves as leaders in sustainability. 4. Future outlook and industry collaboration. The future of sustainability in these industries hinges on collaboration, both within sectors and across them. The interconnected nature of the challenges faced necessitates a holistic approach. Cross-sector partnerships can facilitate knowledge sharing and resource pooling, enabling companies to address sustainability challenges more effectively. Investment in R&D is crucial for developing innovative solutions that can drive sustainability. Collaboration between private firms, governments, and research institutions can lead to breakthroughs that benefit multiple sectors. Consumer engagement is also vital. Educating consumers about the sustainability efforts of companies and the impact of their choices can drive demand for greener products and practices. As industries work towards a common goal of sustainability, they must recognize the importance of cooperation and shared responsibility. By embracing this collaborative approach, they can mitigate the forecasted reduction in sustainability effectiveness and pave the way for a more sustainable future. Conclusion: the projected 40% reduction in sustainability effectiveness across agriculture, automotive, construction, and IT by 2025 serves as a wake-up call for industries to reassess their strategies. By addressing sustainability challenges, leveraging technological advancements, complying with regulatory frameworks, and fostering collaboration, these sectors can turn potential setbacks into opportunities for growth and innovation. The path ahead requires commitment, creativity, and a shared vision for a sustainable future. Here are 3 famous historical cases that illustrate significant challenges in sustainability along with the transformative efforts introduced in response to those challenges. 1. The Dust Bowl, 1930s. United States. The Dust Bowl was a severe ecological disaster that took place during the 1930s in the Great Plains of the United States. It was characterized by extreme drought and poor agricultural practices, which led to massive dust storms that devastated farmland and displaced thousands of families. The situation forced a major rethinking of agricultural practices. In response, the U.S. government implemented measures such as the Soil Conservation Service, which promoted sustainable farming practices, crop rotation, and reforestation. These efforts aim to prevent further soil erosion and restore ecological balance to the agricultural landscape, marking a pivotal shift towards sustainable agriculture. 2. The Exxon Valdez oil spill, 1989, Alaska. The Exxon Valdez oil spill occurred when an oil tanker struck a reef, releasing millions of gallons of crude oil into Prince William Sound. This disaster caused widespread environmental damage and highlighted the dangers of oil dependence and the inadequacy of existing safety protocols. In the aftermath, various regulatory changes were made, including the Oil Pollution Act of 1990, which established stricter safety measures and protocols for oil transportation. This incident also spurred significant advancements in environmental science, prompting the development of better oil spill response techniques and technologies aimed at preventing similar disasters in the future. 3. The Kyoto Protocol, 1997, International. The Kyoto Protocol was an international treaty that aimed to combat climate change by reducing greenhouse gas emissions. Adopted in 1997 and entering into force in 2005. It represented a landmark agreement in environmental diplomacy. The treaty established legally binding obligations for developed countries to reduce their greenhouse gas emissions. The challenges of reaching consensus among nations and addressing the differing capacities and responsibilities of developed and developing countries were significant. The protocol led to the development of emissions trading systems and prompted countries to invest in renewable energy technologies, driving global efforts towards sustainability and climate change mitigation. The dialogue initiated by the Kyoto Protocol continues to influence international climate policy today. These historical cases serve as reminders of the ongoing challenges in sustainability and the transformative actions that can emerge in response to ecological crises. Future outlook: predictions for sustainability effectiveness across key industries by 2025. The forecasted 40% reduction in sustainability effectiveness across the agriculture, automotive, construction, and IT industries by 2025 poses significant challenges and opportunities. This summary explores the potential implications and transformations expected within these sectors as they navigate regulatory pressures, technological advancements, and evolving consumer expectations. 1. Agriculture, shifting practices and technology integration. In agriculture, the integration of advanced technologies such as AI and precision farming tools will be crucial for enhancing sustainability. By 2025, we anticipate increased adoption of AI and precision agriculture. Technologies like drones and IoT sensors will facilitate precise irrigation and crop management, leading to improved water conservation and reduced chemical usage. Focus on regenerative practices. Farmers will increasingly adopt regenerative agriculture techniques that enhance soil health, increase biodiversity, and improve carbon sequestration. Supply chain resilience. As climate change impacts intensify, there will be a push for more resilient supply chains that can adapt to sudden disruptions, including crop failures due to extreme weather events. 2. Automotive, accelerating electrification and circular economy principles. The automotive sector is at a critical juncture where the transition to electric vehicles (EVs) must accelerate to meet stringent emissions targets. Predictions include electrification of vehicle fleets. By 2025, a significant portion of new vehicle sales will be electric, driven by regulatory mandates and consumer demand for sustainable transportation options. However, market hesitation may dampen growth, leading to a slower pace of electrification than needed. Circular economy implementation. Manufacturers will begin to adopt circular practices, focusing on the recycling of materials and the sustainable sourcing of components. This shift will be crucial for reducing reliance on virgin materials and minimizing waste. Enhanced charging infrastructure. There will be substantial investments in EV charging infrastructure, making electric vehicles more accessible and practical for consumers. 3. Construction, sustainable building practices and waste management. The construction industry faces significant challenges in waste management and energy efficiency. By 2025, we expect increased use of sustainable materials. The demand for eco-friendly materials will grow, driven by regulations and consumer preferences for sustainable buildings. Waste reduction techniques. Enhanced waste management practices will be implemented, including better recycling of construction materials and the adoption of modular building techniques that reduce waste. Smart building technologies. The integration of smart technologies will optimize energy usage in buildings, leading to significant reductions in operational energy consumption. 4. IT, sustainable technology and resource efficiency. The IT sector will also experience shifts in sustainability practices by 2025, focusing on energy efficiency in data centers. There will be a concerted effort to enhance the energy efficiency of data centers, which are significant consumers of energy. Innovations in cooling technologies and energy management systems will play a crucial role. Circular IT practices. Companies will increasingly adopt circular economy principles, focusing on the life cycle of IT products, including refurbishment and responsible recycling of electronic waste. AI for sustainability. AI applications will be pivotal in optimizing resource management, energy consumption, and reducing waste across various sectors, including IT. 5. Regulatory pressures and accountability. Across all four industries, regulatory frameworks will continue to evolve, placing greater accountability on companies to meet sustainability targets. By 2025, stricter compliance requirements. Regulations such as the EU Green Deal will impose stricter emissions targets, necessitating significant changes in operational practices. Transparency and reporting. Companies will be required to provide transparent sustainability reporting detailing their environmental impact and improvement efforts. This will drive accountability and encourage more sustainable practices. 6. Consumer expectations and market dynamics. As consumers become more environmentally conscious, their expectations will shape industry practices. By 2025, we predict Increased demand for transparency. Consumers will seek transparency regarding the sustainability of products, influencing purchasing decisions and driving companies to adopt more sustainable practices. Shift towards sustainable brands. Brands that prioritize sustainability will gain a competitive edge, leading to increased market share and consumer loyalty. Conclusion: the forecasted reduction in sustainability effectiveness across agriculture, automotive, construction, and IT industries by 2025 underscores the urgent need for transformative changes. While significant challenges exist, the integration of technology, adherence to regulatory frameworks, and responsiveness to consumer expectations will be pivotal in shaping a more sustainable future. Industries must proactively embrace these changes to mitigate the anticipated decline in effectiveness and drive towards achieving long-term sustainability goals.